Assalamu alaikum. Bismillahirrahmanirrahim. Now we have a second lecture. The course content already discussed in the last lecture, so we move on. Come into the thermodynamics. Thermodynamics basically is a combination of two Greek words. Therm means heat and dynamics means power, as you can see. So in the old time, it is defined as the transformation or conversion of heat into the power. But nowadays it is interpreted to include all sort of energy and energy transformation, all aspects of energy and energy transformation. Now the term is known as science of energy. Like you already studied in inter first law of thermodynamics. Energy can neither be created or nor be destroyed but transformed from one form to another. So it best define its definition, thermodynamics. Now comes to the application. As you already I give a brief description of HVAC, MEP and heat transfer. You can easily identify the application of thermodynamics in it, that all the machine behind the HV system working on the thermodynamics principle. Like we have application of refrigerator. By refrigerator I can explain HVAC system. In refrigerator we are placing hot body, any item which is under the room temperature, like 30 degrees centigrade, we place inside the refrigerator, but the refrigerator temperature is around 3 to 4 degrees centigrade, so or maximum 12 degrees centigrade. So that when the heated body comes into the refrigerator, what refrigerator do, it extract that or it absorb that heat and transfer into the atmosphere outside. You can observe that the grills of the refrigerator behind the refrigerator is heated. So basically what he is doing, the compressor, the electrical energy is converted into the mechanical energy in the form of compressor, and the compressor transfer heat from low temperature to high temperature, because inside the refrigerator there is a low temperature and outside is high temperature. So it's transfer heat from low temperature to high temperature by applying the additional power, and naturally it heat transfer from high temperature to low temperature. Secondly, we have a definition of vehicle engine. Vehicle, we all have engine in our car, motorcycle, bikes, etc. That converts chemical energy into mechanical energy, heat energy. Combustion take place, and then resulted high temperature, pressure convert into the mechanical energy. The piston move to and fro, and that works to run the wheel of the car or generator, etc. Similarly, I have experience of power plants. So power plants also run on the principle of thermodynamics. We are sort of fuels like coal, and crude oil, diesel, natural gas. We all burn this natural gas, coal or any fuel, burn it to produce high temperature and pressure, and then high temperature and pressure produce steam, and then steam, high pressure temperature steam run the turbine, which generate, and turbine run a dynamo electrical generator that can producing electricity. Similarly, we have we have a application of in aerospace industry, where it is a big industry in which we are also converting heat into thrust energy. Simple, air comes in the compressor goes into the combustion chamber, that compressed air combusts and produce high temperature pressure, and that high temperature pressure run the turbine, and remaining hot high temperature pressure gases out from the nozzle that produce thrust, and this thrust is responsible to move the plane. So it's application of thermodynamics. Many other application like this. So now move to next step, definition. Now the basic and starting definition of thermodynamics is system, surrounding and boundary. What is system? It is in the screen you can see that the diagram is well defined. What is system? Anything which is under the consideration, whether it is bounded by any arbitrary or real boundary. It can be arbitrary boundary or be real. So anything under the consideration is system, and the thing which is bounded the system is called boundary, and anything which is outside of the system is surround. It's a basic definition. In initial step engineering analysis describe what is being studied. So if the motion of the body is to be determined, normally the first step to define the free body and identify all the force exerted on it by other bodies. So these are the definition which has written over here. We move on. There's also definition surrounding on boundary. Once the thing are described for analysis, everything other than the system is known surrounding. The real or imaginary surface separate from the system is from its surrounding is called boundary. A quantity of matter that or a region in a space choose for a study is known as system. So it's a basic definition, you can convert into your own words, etc. Now after system, boundary and surrounding, we can identify different type of systems. We have majorly three types of system. We have three type of system in thermodynamics: closed system, isolated system and open system. First of all, very real system is closed system. In the closed system, as you can see in from the figure, mass cannot in, but energy can in or out. For example, you can see from this picture, we are heating the gases under the piston cylinder device. Basically, this is piston. This is piston. Gas is inside of this cylinder. When we heat this system, the gas volume will increase. Keeping the same pressure, the gas volume increase and producing work. So this heat energy converted into the mechanical power, mechanical energy. So energy can transfer. If we consider this piston cylinder device as our system, then energy is transfer from surrounding to system. So it takes place between surrounding to system, but the mass is still under the cylinder, so it is not going anywhere else. So it's a closed system. Fixed quantity of matter is under study. No mass transfer. Energy can be transferred across boundary. Consider piston cylinder. What happened to enclosed gas when it heated. Another very simple system is isolated system. If we from the figure we can see that no energy can takes place in or out between the surrounding to system, between the boundary. Similarly, no energy as well as no mass. So it's a isolated system. Now move to the open system. Open system is very simple system in which both energy and mass come in and out. In any our application, like nozzle, in the nozzle, the water or any gas, just like I've told you, the gas turbine in the engine in the application of aerospace industry, the hot gases goes into this nozzle, and that pressure convert into the velocity. The resultant compressed air combusted, that gain temperature. So the exhaust gases have both high temperature and high pressure, and that energy converts into the velocity, and that resultant velocity by the third law of thermodynamics, every action has a opposite and reverse reaction. So by this exhaust of high velocity gases, this nozzle or connected turbine move in this direction by which plane is flying. So its application of open system, both air and the fuel comes into the combustion gas turbine, and exhaust through the nozzle with the high velocity to move gas turbine engine in the aeroplanes. Similarly, in the IC engine or any car or bicycle, motorcycle engine, the air and the fuel it comes inside the engine, combustion takes place, pressure, temperature convert into the mechanical power, and then mechanical power drives the shaft of any wheel or any generator, and the remaining exhaust gases goes out from the engine. So mass in, energy in, and mass out, and energy can also out. Simple another example is a water heater, etc. You can take all many example. Now come towards the property of a system. Thermodynamics are defined by the properties. Basically, there are two types of properties: intensive properties and extensive properties. Any characteristics of system like mass, pressure, temperature to describe a system and predict its behavior requires knowledge of its properties and how those properties are related. You can easily memorize what are the intensive properties and what are the extensive properties by the starting of intensive with I. So you can memorize that intensive properties is independent of size or extent of the system. I say from I you can relate independent, so you easily memorize what are intensive property. Like temperature doesn't matter with any volume or any extent. For a very small piece of body you have high temperature, and for a high piece of a body you can have temperature high or low, so it is independent. Similarly, pressure, we will study pressure in upcoming slide. You can easily identify why it is independent of any volume, size, or any extent of thing. Oppositely, extensive property depend upon the size and extent of the system, like total mass, your weight. If you have a more weight, you have a if you have a more weight, you have a higher value. If you gain more volume, you get more weight. So this volume, weight, and anything which depends upon the size are all extensive property. Like length is also extensive property. Anything which has related with the extent of the system. To examine property is intensive or extensive, divide the system into two different subsystems. If the value of the property for an overall system is the sum of its values for the parts into which the system is divided, known as extensive. It's a difficult definition, but it's a physical definition. You can divide in the system. You don't have only one property, you have a number of properties. So divide them and check who are depending upon the overall size or extent of the system. Then all those properties are extensive. State of the system, condition of a system is described by its properties. At a given state, all the property of system has fixed values. If the value of even one property changes, the state will change to different one. Basically, it is transformation from in properties, transformation of properties. Number basically, like in first state, the volume is 1.5, but in the second state, the property of the volume is changing from 1.5 to 2.5. So it goes from one state to another. Thermodynamics deals with the state of a balance, no unbalanced potential or driving forces within the system. To see if a system is in thermodynamic equilibrium by the following procedure. So in thermodynamics, we see the balancing, state of balancing around the cycle of the system. So if we need to analyze the thermodynamic equilibrium, we have to isolate the system from its surrounding and watch for the changes in observable properties. Several types of equilibrium must exist individually to fulfill the condition of complete equilibrium. Among these are mechanical, thermal, phase, and chemical equilibrium. From the figure you can see the thermal equilibrium. In thermal equilibrium, the first A is before, that is it is not in thermal equilibrium. So you can see that different position have different temperature. In a particular system we have a different temperature in different position, but if it is goes into the thermal equilibrium, the whole temperature is uniform all around whole area. Like you can differentiate in these two particular pictures. Now comes to the mechanical equilibrium. If there is no change in the pressure at any point of the system with the time, mechanical system, I can draw the diagram over here. If we have a cylinder like this, enclosed cylinder, and we open tab here and tab here, we put water into here, like 2 liter per second, and the same water goes out 2 liter per second. So the water in the cylinder will not the water in the cylinder, the result with the water comes into the cylinder and producing the pressure in the vessel will not change with respect to time, because same water comes in and same water goes out. But if we close the tap of outlet and open of the inlet, the water comes in and producing pressure with respect to time, because the water is flowing with respect to time, 2 liter per second. For each second it is not going out, so it result in increasing the pressure inside the vessel. So if that condition is taking place, then it is not in the mechanical equilibrium. But if it is a first case, it is in the mechanical equilibrium. Second condition, you can understand, you can imagine that if the water is placed is in under the stagnant condition. So in the stagnant condition, the pressure is same, it is not changes with respect to time. But if we heat it, if we heat that cylinder, due to the heating, it producing steam, and then steam is making pressure inside the cylinder. So then still is also becoming a then it is also not in the mechanical equilibrium. So from both example you can understand the mechanical equilibrium. Now comes to the chemical equilibrium. If the chemical composition doesn't change with respect to time, then it is a chemical equilibrium. So similarly, if the solution have no any reaction, any chemical reaction, then it is in a chemical equilibrium. But if it is under the reaction, whether it is exothermic reaction, endothermic reaction, it is reacting with the molecules and producing heat or absorb heat, so then it is not in the chemical equilibrium. Now come to the basic process and path of the process of thermodynamic. Let's understand this. A process is a transformation from one equilibrium state to another. You can see from a particular image that it is a process. The line showing from phase 1 to 2 is a process. The series of the state through which the system passes during the process is called the process of path of the process. So you can see that it is a process path. The series of state through which the system is passing is called process path. The system is said to have undergone a cycle if it is a return to its initial state at the end of the process. Now understand these process path and cycle with that particular example. Consider a cylinder and piston device just like this. We have this piston, and inside there is a gas. If it goes from point 1 to 2, so it compresses the gas. Because it is a closed system, the inside mass is not going outside, so these gases becomes at higher pressure. So plotting this two properties, pressure and volume, in the graph, you can analyze that in the horizontal axis we can take a volume, and from the vertical axis we can take the pressure. and from state 1 to यानी कि from this state we can calculate its volume, its length, its width and its height, and calculate its volume. Like for it has volume of 2 meter cube, but when this is volume, sorry, 2 meter cube, this is 0 meter cube and this is 2 meter cube, but when we compress this gas, the volume is shrink to, let's suppose, 1 meter cube. So volume changes from 2 meter to 1 meter cube, but it is in opposite side. You can see the pressure in first position. Let's suppose it is 2 bar. Bar is also unit of pressure. In first condition it has a pressure of 2 bar, but when we move from state from volume 1 to volume 2, the pressure increase from 2 bar to 4 bar, for an example. So it is inverse of relation, and the law which is defines this is Boyle's law, that volume is inversely proportional to pressure. Now if you have any difficulty, you can note that slide number and ask any question in upcoming live session or Google stream. Now coming to the next slide, the density and specific gravity. Density is defined as a mass per unit volume, and by notation it is defined by the Q, and it is not N, it is M. I will correct in the slide, it is M. It represents the mass in the unit with the kg, and V is volume. So density is defined by the Q is equal to mass upon volume, and the ratio, it is a simple definition of density and the formula of definition, formula of density. The ratio, and what is specific gravity? A ratio of a density of a substance to the density of some standard substance at a specified temperature. So it is a ratio of two densities. On the denominator we set any standard substance, like normally we placed water at 4 degrees centigrade, and the density of water at 4 degrees centigrade, that is standard substance, have 1000 kg per meter cube. The density of water is 1000 kg per meter cube. Anything divided by 1000, like the specific gravity of mercury, it is 13,500. So answer is 13.5. So anything, any specific gravity which is greater than 1, we can analyze that parameter, that it will sink in the water. Anything which have specific gravity is greater than 1, in which we in the denominator we place a water, then it means that it will sink in the water. And for an example, anything which has lesser density than 1000, like any carbon oil, like petrol or diesel, it has a density less than 1. The density of the petrol or and diesel is lower, so the Sg is less than 1. So it means that it floats into the water. You can also calculate the density of any solid object, like for this block, you can calculate its volume and calculate its weight and divide its weight by volume. If it is a density is less than 1000, then this block will float into the water. If its density is higher, then it will sink into the water. You can also identify this with the specific gravity. Now comes toward the pressure. A normal force exerted by the definition, it's a normal force exerted by the fluid per unit area. Normal force means perpendicular force. If it is a object and applying force at a 90 degree, so then it's the resultant pointed area has a pressure of force upon area. For an example, you can it has a unit of Newton per meter square or a Pascal. ठीक है, Pascal is a simple unit. It is from the unit of force is Newton and unit of area is meter cube, so Newton per meter square. But we have different units of the pressure as per MKS system, CGS system, and British system. British system pound per foot cube, foot square something, especially known as PSI, pound per square inch or pound per foot square. It is a British system. In MK system, we are normally taken standard unit as a Pascal or Newton per meter square. Okay, so as in the previous class I told you that we will not only study the parameter by just definition, but with the practical application. So what are the practical application? We have many practical application of the pressure in the solid objects and as well as in the liquids and gases. So first study with the solid object, like I shown two different diagram in which the nail inserted in the wall. So when we place a nail, the sharp end at the wall side and applying perpendicular force through the hammer, it will goes inside and hole in the wall. But if we put that nail opposite, the blunt side on the wall side and the sharp at the hammer side, it will not gets into the wall. Why? Because in this particular in this particular condition, the hammer is applying force, and the force and this perpendicular area, like nail, we have a perpendicular of pi r square, radius square into pi. So this area, and we applying perpendicular force into this. This force is equally transfer into the nail, and in the sharp edge you can see that, you can notice that the force is constant, the force is not going anywhere, but the area of sharp end becomes very less, so the pressure becomes very high. By definition, pressure is force upon area. In first condition, at this end the force is, let's suppose, 10 Newton, but the area is like something, we can take an example, 5 meter square. But oppositely on the sharp end, the force is constant 10, because in metal the force is exactly transferred in the same quantity, but the area becomes 1 meter cube. So you can see that 10 divided by 5 is 2 and 10 divided by 1 is 2. So pressure is increased at the sharp end, and the wall cannot sustain that pressure, so the hole, it insert into the wall, it breaks the wall and make the hole. Every solid have object, you can analyze your in upcoming civil engineering discipline, that all you can study the materials. You have a material testing lab. Every RCC concrete slab or anything which has a particular sustainable pressure, if the pressure applied on it gets bigger than its applicable pressure, then it breaks the wall, it breaks the slab, etc. So in here, by the changing the shape of a solid object, we can convert, we can transform pressure into different values and get benefit and get make it many application. Similarly, you can analyze whatever I've drawn. You can easily see in this that in that particular area, the same, if it is same shape, same force applying here and same force applying here, but by making sharp edge we can increase the pressure, like in the example of nail. So I think you will understand the concept behind the pressure. It's not just a definition, force upon area, but it's a big application in materials, in liquid and gases. Now comes to the application in the fluids means both temperature, fluids means both gases and liquid. In thermodynamics, the terminology fluid contains both gases and liquid. So you can see easily the application of hydraulic and gases in this particular system. You might go into the car washing area. The car plays inside the ram, and it will eject from a piston, and you can see that the person is only open the wall of a compressor. It's a very 2-inch line, and then that high pressure goes into the cylinder, and that cylinder pull up the car. So here we are doing oppositely. In the previous application we are transforming pressure and construct the force. In the liquid, in the gases, the thing has been done oppositely. Okay, let's suppose this piston cylinder device is filled with any liquid or any gas. If we apply force like 10 Newton with the area of 0.5 meter square, it producing some pressure, and in the liquid or in the gases inside the cylinder, it applying pressure in its all direction equally. So same pressure is applying over here. Let's suppose what is the pressure? 10 divided by 0.5 is 20 Newton per meter square. So it is a 20 Newton per meter square. But the same pressure is applying over here, and now how much the area is increased from 0.5 to 12.5. So you can calculate the force. You can same 20 Newton or 20 pressure is same 20 Pascal. Like I've told you that you can easily calculate the pressure. Now from the same pressure you can calculate how much force it can produce. So simple, by increasing the area we can increase the force. So basically it is a mechanical advantage. We can take mechanical advantage in the gases, in the liquid, in this way. Now we are pressure making devices. We have simple definition, simple mechanical machines. For liquid to produce pressure we have a device called pump, and in the gases to produce pressure we have a device called compressor. Now you can see the application of the pressure in your homes, in car washing area. The pump is running and increasing the pressure into the water, and that pressure goes from the nozzle and making high velocity jet of the water, and that high velocity jet cleans the dirts in the car. Or in the application of compressor, you can take example of tire inflation. You can see in the tire shop there's a vessel, and above the vessel there is a compressor. So compressor is taking air from the outside and compress it, making it more pressure and sent into the vessel, and vessel is holding high pressure, and that high pressure is used to lift the car, is used to inflate the tire of a car. The pressure inside the car is twice of atmosphere pressure. Atmosphere pressure is 1 atm, and the inside of the tire it is 2 atm. Or if we talk about in the terms of bar, so outside of the tire atmosphere pressure is 1 bar, and inside the tire is a 2 bar, so it is inflating. You can also take example of a pressure in the I can draw it like here. Like the compressor is filling this vessel with the high pressure. If the valves open, high pressure gets outside the atmosphere pressure, just like example of tire. But If inside the pressure is lower, outside atmosphere goes into the this vessel. Example of vacuum pump. So I hope by different mechanism I understand give the understanding of pressure in different application, in the metals, in the solids, in the gases, and the or in the liquids. Another example you can see from the bottle, pressure in the liquid especially, uh, like in this example I'm telling the pressure exerting in all direction equally, but in this direction the pressure is not same. You can easily understand when we fill the bottle and make hole in different height. So in a higher height we have a low pressure, but in the bottom we have high pressure due to the weight of the water, because here the whole weight of the water exert into here, and which produce pressure. But on the upper hand only this amount of water weight is applying here, or which result the pressure. So but if I filled it with the if I filled with the gas, air, you can see almost zero difference between this pressure and this pressure due to the weight of air, because the weight of the air is very less, so it will not producing dominant effect. But in the liquid is very have a high weight, high density, so it producing different it makes dominant effect. But if the volume is so high, as I've told you the example of air in this bottle, it is not giving significant effect with respect to height. But let consider our atmosphere. In the sea level we have a high pressure, like I can draw the earth atmosphere. This is earth, we have a different layer of air around the air. On the sea level we have a very high pressure, maximum pressure, not high, but the maximum pressure, that is 1 bar. But if we fly above the through any device, that like a plane above 13,000 feet, 14,000 feet, we can see the atmosphere pressure is lower than 1 bar or 1 atmosphere. It is 0.9, 0.5, 0.6. So on the sea level, why it is 1 bar? It is the weight of whole air, whole uh, different layer of air. But as we goes above the sky, we are crossing the layer and the weight of the air is decreased. And when we outs all the 7 layer of the atmosphere, we have a zero pressure, that is a vacuum. So by these definitions and applications, I hope you well understand the application of the pressure. If it is a routine regular class, then it will be more informative, because you have I get your queries and timely questions. So it is it will be more interactive. Anyhow, due to the COVID situation, I'll try my best to put that interactive and making diagrams on the planes. I'll see you inshallah in the next lecture. Stay blessed. Khuda Hafiz.